Hi folks, welcome back to Math with Captain Rod. I'm making this video here to just provide some examples again of factoring. And these examples, I'm going to go through them. We're going to look at the following four examples. This one, this one, this one, this one. Over on the left, this is just some details so you know where they came from. This example is on page 48. It's number 14, and it's the one I'm calling example 1. Example 2 is number 26, same page. Example 3 is number 12 on page 47. Example 4 is number 22 on page 47. So let's get started. This stuff's exciting. So looking this guy over, one thing you need to notice is that, all right, the x is cubed, the y is cubed. Also, 27 is a perfect cube. 27 is equal to 3 cubed. All right, and looking over here, this 64 is a perfect cube as well. If I take, let's say, I believe 4 times 4, you get 16 times 4 more. You'll get 64. So this thing right here is the sum of two cubes. The only trick here is recognizing what it is that's being cubed. In this spot here, what's being cubed is 3xy. So we could kind of rewrite this term here. I'll do it right under here. 3xy, the quantity cubed, plus, now we're looking at this guy. This animal is equal to 4 cubed. So recognizing that we're looking at the sum of two cubes, I've already written down the formula up here for factoring the sum of two cubes. It's just a matter of identifying what the a and the b is. So in this case, a is 3xy and b is 4. So this is going to factor into 3xy minus 4. Right, there's my a minus b times the quantity a squared. And again, this is a, 3xy, so that's going to be, how about we write that 9x squared y squared minus a times b. So let's write that 3xy, there's my a, times my b, which is times 4, plus b squared. I'm going to go ahead and just write plus 16. Now, there's a slight simplification we can do. We can do this product and make that a 12. I'm just going to call that done and move on to the next problem. All right, this guy right here, 3y to the n plus 64. So I chose that one to do as an example because it's kind of maybe a funny looking one with that n in the power. I'm going to talk a little bit about what we can do with this. Again, just like before, 64 is a perfect cube. And this is also a perfect cube. This can be written, I'll write it over here, y to the n cubed. Remember, when you raise a power to a power, you multiply exponents. So this thing that I've written down here is equal to y to the 3n. And then, just like before, plus 4 cubed. So it's just a matter of first recognizing we're looking at the sum of two cubes, right? And then second, recognizing what the a and b is. In this case, it's y to the n that's being cubed and 4 that's being cubed. And I'll just go ahead and apply this formula again. So now we're going to have y to the n minus b, whoops, I'm sorry, not b, y to the n minus 4, right, there's my a minus b term, times a squared. Now if I take y to the n and square it, that's going to be y to the 2n, minus a times b, and I'm going to go ahead and write that 4 times y to the n, because that just sounds nicer than y to the n times 4. So again, this is my a and that's my b. I just changed the order to make it look a little bit nicer. And where are we at here? Oh, okay, plus b squared. So plus b, which is 4, squared. So I'll just go ahead and put plus 16. So this animal now factored. Right. Example 3. So we look this thing over, and there's no cubes anywhere in sight. And we go, okay, that's fine. Notice that this left-hand side we can write as x times y, the quantity squared, minus 1 we could also write as 1 squared. So this is the difference of two squares. And the difference of two squares, I'm going to write this over here, a squared minus b squared factors into a minus b times a plus b. So this is going to factor into, okay, a minus b. That's going to be x times y minus 1. And then times a plus b. That's going to be x times y plus 1. And that's done. Fourth example here. This guy, just sitting on page 22. So we glance it over. We notice it's a trinomial. It's got that middle term. So this is not a difference of two squares or the difference of two cubes. Another common thing, we look it over for common terms. I don't really see any. This isn't even, so I can't pull out a 2. This is not divisible by 3. So there's not really much we can pull out of this. So what we'll do here is we'll take this guy and we'll start trying to kind of a trial and error type of approach. Okay, noticing that this is a 4 and this is noticing a 4x squared here. So possible combinations, 4x and x. And I'm gonna start going down that road, 4x and x. And then you would look here and say, well, what are the type of numbers that can give me that 81? So possible combinations here would be like 81 and 1. Also notice that 9 and 9 would do that. And we might try 9 and 9. And when you multiply this out, all right, the 4x squared term will work, but this outer term gives 36x, middle term gives 9x, and that's just not what we're looking for, because that's going to give us, what, 45x. So this isn't going to work. So we'll go back and try the 4 and 4. Or, I'm sorry, the what was I thinking here? Oh, backing up. So we talked about the 81 and the 1. That's not going to work. 4 and 4 didn't work. So we go back to the original and say, okay, this 4x squared here. Well, I tried the 4x and the x didn't work out as well as I would have hoped. So maybe we try 2x and 2x. And maybe we try the 9 and the 9. And you'll notice when we multiply this out, 4x squared, this is going to give me plus 18x, this is going to give me plus 18 more x, and this is going to give me a plus 81. So this is the correct factorization of this. Now, there's kind of a format for recognizing what's called a perfect square trinomial here. You'll notice that this is equal to 2x plus 9, the quantity squared. I chose to talk about this in terms of just a trial and error type approach, because that's a little bit more general type of approach. Once you do a lot of these, you'll be able to look at polynomials like this and tell when they're perfect squares or not. But I've chosen this particular one just to talk about using this trial and error type of approach. So I hope these examples help you get through your homework. Have a great day.